So hello everyone, welcome to my video. Today I'll be teaching you guys about chapter 8 of MS Form 5, which is kinematics. Now kinematic is one of the easiest questions to score in second C, bahagian C, because out of the 4 questions, kinematic is one of the easier ones, and the other one being indeks kubahan, composite index, something like that, and then the rest is triangle, segi, tiga, or the graph, which is from 5 up 7. But we won't be getting into those because I feel like kinematic is a lot of people that's lacking on, because it is the last chapter of Form 5, so a lot of people skipped it. So today we'll be learning about kinematics. So what is kinematics, you may ask? Kinematic is basically like this. The only thing you have to worry about for 3 units is displacement, sasaran, and then we have velocity, halaju, and of course acceleration, pecutan. Okay, so what is the difference? Now you have learned this in physics before, right? The second chapter of Form 4 of physics of sasaran and halaju, pecutan. Okay, so it's like this. Displacement, of course, has area. I mean, not area, magnitude and direction, magnitude and vector. Sorry. So, for example, I walk to front 4 meters, and I go back for 2 meters. Your displacement will be 2 meters, while your distance will be 6, because distance is basically everything in total, but displacement or sasaran is in 2 because it will be your final direction. So this is going to be important because later on there will be one question that will ask the total distance for donkey, I think. Yes, for most of the kinematic questions, total distance is always going to be asked, and so on. We're going to move on to velocity, halaju is basically just speed. So the formula, there's no formula actually. Okay, one thing for sure you need to know is that if you order to tukar to S to V and then to A, or A to V to S, there's one thing we need to know. From S to B, we have to differentiate. Okay, the one thing I like about this chapter is because this dy dx, because it involves differentiation and integration. So since we have learned that in bab 2, bab 3, and a lot of people liked it, so that's why this chapter is quite good, is because it actually tests your differentiation and integration skills. So S to V, we'll be using dy dx, of course, and then V to A is basically also dy dx. So basically, if you want to tukar from S to A, we have to do d square y over dx square. While if we do A to V, we have to integrate. Now integrate, this will be slightly different compared to the one we did for a lot of questions in integration, where there's a number at the top and the number at the bottom, right? That is what we call an integral. I think it's tak tentu or something like that. I forgot in BM. But integration is like this. For kinematic, you have to always have a plus C once you integrate, because for example, I put ax plus 5. Remember, I integrate it, so it become 4x squared plus 5x plus c. Because you don't know this number you don't know, because it can be either 4, it can be 5, it can be 99. You don't know, so you have to put a plus c. It's the same goes to kinematics, because we have to sub in something in order to get the c, because later on we're gonna apply this in a few questions. I'm gonna give you guys a few examples actually. Okay, the first question is, okay, so basically you guys can look at BM or BI, wherever student you are. You're either a BI you're a DLP student, or just a regular student like me lah. Okay, but I look at BI, of course. Okay, a particle moves on a straight line and passes through a fixed point O, and then its velocity velocity v ms negative 1 is given by v equals to t squared minus 6t plus 8, where t is the time in seconds after passing through O. So you say assume motion to the right is positive. So what it's being telling is that most of these questions will say assume motion to the right is positive, which means when you're going to the right, is positive. If you're going to the left, is negative. So that's what they're trying to tell. And okay, so let's go back. So they say find halaju minimum, the minimum velocity. Okay, Remember we learned in chapter 2 where there's a formula we can use to find the minimum, which is going to be when dy dx equals to 0. This is for example this is going to be for example like this. This is your quadratic, right? This will be your minimum, so this is your titik minimum. So when it is always when dy dx is equals to 0, which is basically your keturunan, your gradient. So this basically applies to the same as kinematics, where it reaches minimum halaju. So you have to use dy dx equals to 0. In this case, it's called dv over dt, but we don't write it like that in kinematic. We write just straight in s, a, or v. So okay, halaju minimum. So we're gonna write the formula down. So we're gonna write the formula down right here. Okay, we're gonna go to next page. Sorry. Okay, so the formula is v equals to t squared minus 6t plus 8. Okay, you see, right? You see, assume to go to the, it goes to the right is positive. It says it's halaju minimum. So when it's halaju minimum, of course we need to differentiate v first, which is also known as a. Remember, v to a, you have to differentiate dy dx. So in this case, it's supposed to be dv over dt, but we don't write like that. We just write a. So if you differentiate, you get 2t minus 6, right? And then after that, remember, dy dx is equals to 0 when it's minimum. So that's the a will be equals to 0. So 2t minus 6, you will get t equals to 3 seconds. Okay, so this is when this is 3 seconds at the third second when the velocity is minimum. So we sub this back to the v formula. So v equals to 3 square minus 6, 3 plus 8. You will get, so if you use calculator, it should be -1. So you get your answer -1, which is correct lah. So it will be -1 ms -1. You get -1 ms -1. So this is the correct answer. So we're gonna move on to B, which is here real quick. Okay, find the range of value of t during when the particle moves to the right. Juga nilai t apabila zarah bergerak ke kanan. Okay, what this means? What happens basically when it moves to the right? What is it? Positive or negative? Of course, it is positive, because when you go to the right, it's positive. Like I said just now, when you go to the right, it's positive, which means that your value, your v value must be bigger than 0. So we need to write it down. Write the formula down. T squared minus 6t plus 8. 6t plus 8 will be bigger than 0 because your v must be bigger than 0. So that's why I put v bigger than 0. So if you use the calculator, if you put in quadratic mode, 1 negative 6, 8, you will get t minus 4 and t minus 2. Alright, so now we got this. Remember in Form 4 Chapter 2, we have learned that. I need to teach you guys a concept that I have maybe forgotten. So when it's bigger than 0 or when it's bigger equals to 0, your quadratic graph, you draw a quadratic this is what we call the shape cup, the cup method. So it's basically like this. If it's bigger than 0, it will always be on the outside of the cup. This is the cup, you shake outside of the cup. So for example, in this case, this scenario, if it's t minus 4 and t minus 2, which means your two t's will be 2 and 4. Now in this case, we will have two different types of range. So the first one being that the t value is smaller than 2. So we need to write t is smaller than 2. But remember, in this chapter, t cannot be less than 0. So we need to put a statement saying that it cannot be more than 0. It cannot be less than 0. Sorry, it cannot be less than 0. So that's why I put this. And then on the other hand, this part right here will be bigger than 4. So t will be bigger than 4. So these are going to be your answers. These two are going to be your range. 2 marks. Done. And the other one is smaller than 0. When it's smaller or smaller equals, they're the same. It will be inside the cup. It will be here. And then your 2 and 4 should be here, so that your range can be only one, which is within this 2 and 4. So it is t 4. So t is bigger equals to 2, but it's smaller equals to 4. So that's how you get it lah. This is with the concept, and while this one outside the cup is when it's bigger or bigger equals to 0. They're the same. Okay, let's move on to the next question. Alright, now they ask you, now they ask you to sketch the velocity time graph of the motion of the particles with this range. So you want to get 0 all the way to 4. So you need to draw a table out first. You need to draw a jadwal out. So let me draw a jadwal out for you. So you need to get t from 0 to 4. So you draw a table out with t and v, and then you have to write 0, 1, 2, 3, 4, and then you draw a table out. My table is not the best looking, but please don't draw like this in the exam in SPM later on. Okay, here you go, 0, 1, 2, 3, 4. Okay, now you basically just sub it into the equation just now, which is v equals to t squared minus 6t plus 8. You just sub every single value from 0 to 4. So if you do that, you will get a very good answer. Let me 6c plus 8. If you sub in 0, you'll get 8 here. So this is 8, and this will be 1. So it's 3, so it will be 2. It will be 0. So as you can see, it is going to the left, because it is, I mean, it's not going to the left, it's going the other direction. Yeah, it's going the other direction. So as you can see, it's going down like this. As you can see, right? 8, 3, 0, negative 1, 0. As you can see, it goes back to 0, which means it goes negative 1 and then it stops at 0 again. It stops at it actually stops at 2 and 4. This is what we got from the previous question, right? We got this. So it will stop within these two seconds, 2 and 4. So if you draw the table, once you draw the table, you can draw a graph. So you draw a graph like this. Not the best looking graph, but please don't do what I did. Don't do what I'm doing right now. So you draw it beautifully. Okay, 0, 1, 2, 3, 4, and then you write the velocity. Okay, since they ask for sketching laka only, so you don't have to write like a full graph like 1, 2, 3, 4. You don't have to do like this. This is not necessary because you're wasting a lot of time in this case. Sketching just means like a very simple graph. You don't have to draw an actual full graph. Okay, since there's a -1, we have to extend it all the way to a -1. So 8, 0 will be 8. So we draw 8 out here, and then we write a 3. 3 should be around here, just aga only actually. So 0, 8, so it will be here. And then on 1, 3, your coordinate is 1, 3, so it's here, 1, 3. And then 2 will be at 0. And then 3 will be -1, so it's go all the way down here, and then 4 will be 0 again. So if you draw the graph out, you can see a quadratic shape, which is correct in this case. Okay, don't draw like this. This is very weird. Okay, if you draw like, draw this. Something like that. Yeah, that means you have officially drawn the graph correctly. It's a quadratic graph. This is the titik minimum. Remember what we did in the first question, where this one right here, -1 and minus -1 is this titik minimum, which means when it actually is when it's dy dx equals to 0, which you can see dy dx is equals to 0 here. Dy dx is 0, right? So you got it correct lah. This is basically how your graph is going to look like. So that's how you get another 2 marks. Okay, now for question D. D is they want you to find the jumlah jarak. Yes, they want you to find the jumlah jarak, the total distance traveled during the first 4 seconds after leaving point O, which means it starts from 0 of course. So, okay, in this case, the total distance. Okay, one concept you have to remember is that the velocity over time, the hala jumlah 1 masa graph, you need to know that the area of this is going to be your sasaran, because what we learned before, if you write the formula down, if you do like this, remember the formula is equals to S over T, or sasaran over masa, the displacement over time equals to V. And then if you do ms -1 equals to S over, sorry, not S, is meters. This is in unit SI, by the way. If I write in meter over saat, if I sub this here, you will get M equals to M. So which means you want to times, so VT equals to S. Yes, you have to times velocity and time. So that's how you get sasaran. This is why it's the last. Okay, now in this case, how do you solve this? Now, for this particular question, you need to know that when it's going here from 0 to 2 seconds, this will be your area, which is your sasaran, right? It's sasaran. This is your first sasaran, and this will be your second sasaran, right? Because it's going back. It's going back to the left, which means you have to separate into two. Because on the top, the first part of the graph is on the top, the second part of the graph is on the bottom. So we need to do you need to find the total distance, right? This is total distance, by the way, is S1 plus S2. Okay, how are you going to get that? Of course, you have to do integration. Okay, integration in this case, you have to use the kamil, which means you have to, there's a value on the bottom, top and the bottom. So for example, 3 to 0 is from 0 to 3 seconds, something like that. So we have to do like this. So we have to split it out first. Okay, let's find S1 first. How do you find S1? You have to integrate from 0 to 2 because you want to find the area from 0 to 2 to the, because it's going to the positive, right? It's going to the right. So you have to integrate this. So you need to find 2, 0, and then you have to basically integrate your formula, which is t squared minus 60 plus 8, because we basically v lah dt. So you have to find the area. So it's actually just t squared minus 8t plus 6, if I'm correct. Oh, sorry, minus 60 plus 8, minus 60 plus 8 dt. So you just integrate it. So you get 1 over 3t cubed minus 3t squared plus 8t. You will get 2, 0. As you can see, now we just do normal integration lah. So we just 2 cubed minus 3, 2 square minus plus 8, 2, and then minus 0, because if you sub everything is 0, so you have to write another additional step. So if you get the answer, if you solve it, you would get 20 over 3. You will get 20 over 3 meters. Okay, this is going to be the first part of your graph. This is the first part, and now we're going on to 2 to 4, which is this part down under the graph now, under the x-axis. So we need to write S2 is equals to integrate 4, 2, and then v squared minus 60 plus 8 dt. So again, you do the same thing. You integrate 3 over 3. No, sorry, not v. Oh wait, this one, wrong one. You get t squared. So it's 1 over 3t cubed minus 3t squared plus 8t. Same thing only. Same thing only. Now you just sub in these two. So if you use the calculator, you should get a different value. You will get s equals to s2 equals to, so you get 1 over 3 4 cubed minus 3 4 square plus 80, right? Yeah, plus 80 minus 1, okay, sorry, 1 over 3 2 cubed minus 3 2 square plus 8 2. You will get, okay, if you want to do quick step, you just use the calculator method. So you do calculator method is x squared minus 6 plus 8 integrate to 4. You will get negative 4 over 3, but of course it is not negative. You will get negative 4 over 3, but we write 4 over 3 of course, because remember it cannot be negative. Area cannot be negative, of course. So you get 4 over 3. Yeah. So as you can see, now we got 2, we just plus them together. So your total distance will be 20 over 3 plus 4 over 3. You will get 8 meters, and this will be your final answer for total distance. So basically, in summary, starting for the first question, remember hard laju minimum is basically you differentiate dy dx equals to 0 because it reaches the minimum, so your gradient or your keturunan is 0. And then so you remember, B to A you have to do differentiation, A to B you have to do integration. Remember that this is the step you have to always remember. And then after that you will find the second, and then after that you sub in there, you get your minimum halaju. And then after that, the second question is, because they say bergerak ke kanan or move to the right, so it is bigger than 0, because if you move to the left it will be negative, so it must be more than 0. Why cannot be more equals? Because 0, it cannot be 0. It moves to the right. If it is at 0, that means it is moving, is in stationary mode, bagun, keadaan bagun. So you have to write bigger than 0. After that, you have to do remember the cup formula I taught you just now, is when it is bigger or bigger equals, it will be outside of the cup. But when it's smaller or smaller equals, you have to do inside of the cup. And then so you do these formulas. And then for the sketching question, you just basically draw the table out, and then you do t square minus 60 plus 8, you sub in everything, and then you draw the graph out. Simple enough. And then D is basically you integrate from your halaju master graph. Remember what we learned? So it's like that. And that's pretty much it for kinematics. I hope you learned something from this video, and I wish you all the best for SPM. Thank you very much.